Hello, good morning everyone. I'm Akanksha. Today I'm going to explain about my Automata theory project that is on library management system. My CWID is 50306620. I am here today to explain my Automata theory project, which is to build CKY parser on library search operation. As we all know, libraries play important role in our society. The resources and services they offer create opportunities for learning. The main purpose of this project, library search operation allows you to search for books held by library or subscribed to the library. This is a library book search operation here. Here user can search the books in any library by asking some questions. The CKY method is a grammatical membership algorithm that does not require any context. It is used to see if string matches the given grammar language. The CKY algorithm or Koki-Younger-Kasami algorithm is named after its founders. To utilize the CKY algorithm, the grammar must be in the Chomsky normal form. It uses dynamic programming approach to determine whether string is the grammar language. The CKY method applies grammar rules to the substrings of increasing length. The time complexity of early technique will be reduced because of its upper bound is big O of N3. What is the backbone of building the CKY parser? CKY parser is built by converting CFG. CFG is nothing but context-free grammar. It should be converted into its equivalent CNF. What exactly is the CKY parser? CFG is a context-free grammar. It is having a set of recursive rules used to generate the pattern of strings. CFG is used to decide whether the given string belongs to the grammar or not. CFG is having following rules. It is a set of 4 tuples consisting of 4 rules, non-terminal, set of terminal, set of rules, and a start symbol. Any CFG will automatically have CNF if it satisfies 3 prediction rules. Non-terminal generating a terminal, non-terminal generating 2 terminals, and a start symbol generation. For any grammar, there can be more than one CNF. CNF can be used as pre-processing many algorithms like membership operator of CFG. In this library search operation, we need to build a CKY parser. In order to build a CKY parser, you have to first build the CFG, then convert the CFG to the equivalent CNF. Then we need to build CKY parsing table. In this, we need to have few valid statements. And through which we can understand whether the CKY parser is valid. And we also need to have a few invalid sentences so that we can see that whether the grammar is valid for checking the invalid sentences. These are all valid sentences that we usually use in library search. These are few invalid sentences. Along with that, we also use invalid sentences which does not generate parser, which does not have grammar. The parser will return no. The code for this is actually written in Python, and I have executed this code in the Jupyter notebook. This is actually a CFG which is used. The CFG having one terminal The CFG is having one terminal and two non-terminals or two non-terminals. This is the CFG. We converted it into equivalent CNF. For each table, we have to build the CKY table. For each sentence, we have to build a CKY table to parse the sentence, including three to parse the sentence. We also try the same for the invalid sentences to check whether it's valid or invalid. By this, we can understand the parser is nothing but it parses the input which we give. It is valid if it's a valid one. It throws yes, else it throws false. No. This is the parsing tables for the valid sentences. These are the snippets of those valid sentences. These are the tables for the invalid sentences. This is how parsing for invalid sentences are done. This is the code snippet or code snippet. I'll show execution also. First, initially we have loaded a grammar a.text file into this. Thereafter, we written the logic of the code here. And if the sentence is valid, flag value will written as. If the sentence is invalid, the flag value will written as no. Then let's go to the execution part. Let's check the execution for these valid sentences and invalid sentences. Yeah, the library has that book. As sentence is valid, the parser will return S. The flag value will be S. Then let's check for another sentence. Now I'm going to show the execution of this. The library has that book. As the sentence is valid, the parser, the flag value written as S. Then let's consider another sentence. Check the book. As even this sentence is check the book is also a valid sentence. So the parser written S. Then let's take another valid sentence. Check in the book order. Even this sentence is valid, so the parser return its value as S. Let's see, and the sentence, search the library. Even this sentence is valid, so the parser written S. Then let's check it for another sentence. Even this sentence is valid, so the parser written S. Even this sentence is true, so the parser written its value as S. As the sentence is true, the parser written this value as S. Finally, I would like to conclude this by extending my gratitude towards our professor, Dr. Sangsu, who helped us for enhancing our knowledge in Automata Theory project. Thank you.